Welcome back to the Rice Robotics Club Robo-Tutorial. You made it this far, great job. You've pushed through a lot of parts already. I appreciate that you're going all the way through. And we only have a few more parts before we get into actual assembly of the parts that we've been CADing. So well done, keep going. For this video, we're going to be designing this first link, and I'll show you what it looks like by itself. It actually has two bodies. It has this body, which will attach to the servo horn here, very similar to how the pulley will attach to the servo horn. And then it will fit nicely into the rest of the first link. And whenever this turns, this will turn together because of these keys that we have included here. So we're going to go back to our Onshape document. We're going to go to the file select and create a new part studio. Okay. And we're going to start by creating that rod, the smaller body that I showed you just a second ago. Create a new sketch. It's going to be on the top face here, top plane. Right click to reorient your view. Now we're going to sketch a circle centered at the origin. It's going to have a diameter of 15 millimeters. And this is a very simple one. We're just going to extrude to a depth of 24 millimeters. Now I'll show you a new extrude feature or extrude tool you can use here. So here we extrude all in one direction. If you want to do some other kind of extrude, you can either have a second direction or a second end position. So you can extrude in both directions. Or what we're going to do in this case is we're going to do a symmetric extrude, which means it extrudes with this depth, but it extrudes evenly on either side of this plane, which is going to be very convenient for us in this case. If we wanted to do this without using a symmetric extrude, we'd have to actually create several more features to do what we're about to do. So I'll show you as we go through why this is more convenient. So we're going to use a symmetric extrude. Depth is 24 millimeters. Confirm that. Okay. Okay, and we're actually going to very quickly see why this was more convenient to do the symmetric extrude this way. We're going to create a new sketch on the same plane, the top plane. You'll see since we did this symmetric extrude, the top plane actually passes straight through the middle of this cylinder. That's exactly where we want to start our key pieces. I showed you earlier, these keys that will engage with the first link. So in this way, we've saved ourselves some steps by just allowing us to use the top plane again for this next feature. So we're going to select the use tool, and we're going to project this circumference onto our sketch plane. Okay, but we don't actually want that to define our feature. We just want this for reference, convert it to construction geometry. Okay, and now we're going to start adding our key pieces, which are just going to be rectangles. So we're going to select the center point rectangle tool. We're going to draw a rectangle that's going to be coincident with the circumference of this circle and vertically aligned with the origin. Okay, it's going to be centered at that point there. And then we'll have to specify its size with some dimensions. It's going to be 3.5 millimeters tall and 3 millimeters wide. Okay, so this is one of our keys, but we're going to need 3 more throughout so that not all of the force is on this one key. It's kind of a small piece. It may break if we put too much weight on it. So we're going to divide that force between 4 different keys, which is going to improve the reliability of our part. So I actually don't remember if we've done this yet, but we're going to use what's called a circular pattern. So a circular pattern inside of a sketch allows you to duplicate a sketch entity multiple times around a circle. So I'll show you what that looks like. Up here, this is like the pattern menu. Select circular pattern. Okay. And then we want to pattern this rectangle. And it automatically goes around this circle. Okay. You can see we have 3 of them. We actually want 4. So where it says 3x, we're going to double click, type 4. And now we have 4 keys like we expect to see them, which is great. So now we're going to confirm You can see this is still underdefined, right? We have 4 keys, but they're still blue, which means we need to add some other constraint to them. Because if you drag it, there's nothing to actually hold these in that in the circle that we want them to stay in. So we need to make the center point of the circle that has all of these keys coincident with the origin, and that'll snap everything into place. So select the coincident relation, select this point and the origin. Oh, and everything snaps into place. So this is now fully defined, and we can add an extrude feature to get the keys in place. Okay, so this is going to be another symmetric extrusion, and we will be extruding with a depth of 8 millimeters. And now we have these nice key pieces that will help us connect to link 1. Okay, now we get to learn another new feature. It's called the loft. The loft is you give it multiple vertically aligned sketches, basically sketch profiles, and it will automatically connect them and turn them into a new body. So I'll show you what that looks like. We're going to start by having to create a new reference plane for our sketch. Okay, so come up to the feature toolbar, select plane. It's not going to be a tangent plane like it was last time. This is just going to be what's called an offset plane. So we're going to choose a surface that we want this plane to be parallel to, and then we're going to say how much distance there is between them. Okay, so we want this plane to be above this cylindrical piece. So it's going to be parallel to this face, and then it's going to have some certain offset here. Okay. In this case, we want a 10 millimeter offset. And then we're going to confirm that plane. And now I want to create a new sketch on this plane. So select sketch, select the plane, denormal the sketch plane. Okay. Now we're going to draw another circle, also centered at the origin, but it's going to be a little bit bigger than the rest of our profile here. It's going to have a 30 millimeter diameter. So add a dimension that specifies a 30 millimeter diameter. Okay. Now, if we rotate here, you'll see that we have this 2D sketch and it's aligned vertically with the top of this cylinder. And so now if we use a loft feature, we can give it this sketch profile and this sketch profile, and it will automatically connect them in a new feature. It'll kind of be like this, I guess it's like a truncated cone, okay? So we're going to create a loft feature. It's this one right here. It's a loft. It's going to ask us for the profiles that we want to connect, okay? So we're going to select circular edge here, and then the sketch that we just created. And now it adds like this truncated cone shape like I was talking about, okay? So it looks kind of cool. Make sure that you're adding material and not creating a new body. Just adding material. Click the green check mark. And now we have some more complicated geometry. The reason we want this is because we don't want this full diameter to have to engage with link 1. We want a smaller diameter here. We need a larger diameter here so that we can fit all of these holes for the servo horn. So that's why we're doing it. We're also doing it because it looks kind of cool, and I like it. So that part is done. And now we need to add a section here, a cutout, so that the servo horn can fit nicely into the rod here. And it's actually going to be the exact same profile we used in the pulley. So let's go to the pulley. We're going to find the sketch that defines the cutout into this pulley, which I think should be, yeah, so remember we named this servo horn cutout. So we need this sketch. And we're going to right click that sketch and then copy it. We're going to go back to our new part studio. Right click here. We're going to click paste sketch. Okay. And now this sketch is underdefined. It's kind of in place, but we haven't fully constrained it. So right click, edit the sketch. Now, I want to say all we have to do is set this to be coincident with the origin. We'll be good to go. Honestly, I'm not totally sure that's going to do it, but we'll see what happens, okay? So select the coincident relation, click the center of this circle, and the origin. Okay. Not quite. What else do we need to do here? Okay, forget that. That's not the way to do it. Turns out. So I learned something new, and now you get to learn it with me like 5 minutes later. This is clearly a mess. You can fix this if you apply enough like constraints. But whenever we have such like it's like pretty complex geometry. Whenever we try and copy and paste it, it's gonna have a lot of issues, and it's gonna be difficult to fix. But there's a better way. So let me show you. Just gonna get rid of this. We don't want it anymore. You can actually just directly pull a sketch from a different part into this part studio, and it'll always be like referencing that original sketch. So if we change that original sketch, it'll update here. It's actually better than what we were about to do. So we need to use a new tool. It's called the derived tool. Okay. Right here, I'm just going to go up to the search bar, search derived, click derived. Okay, so this allows us to, within this Onshape document, we can take parts, features, or sketches from other files in here and just bring them into this part studio. So to do that, we're going to click select part studio. We don't want any parts, but we're going to click the pulley drop down. And here you can see we have all of the sketches that we might want to project into this part studio. And this is that profile that we want to use. So select it. Now it's been added. It's not in the right place though. This is where it appears in the original part studio, but we want to shift it so it's actually on this top face. Okay. So to do that, we need to select a location. So we haven't really discussed a make connector yet, but a make connector is this thing right here. It's a reference frame. It shows three axes here. I guess it's not really a reference frame, but it shows three axes, and it's used a lot whenever we start putting together assemblies to fully define like how two bodies relate to one another. So in this case, it's just going to tell us where the sketch needs to be. So we're going to select a location, and we're going to add a make connector to this top face. And now this point is like acting as the origin in the pulley sketch, or in the pulley part. It's kind of confusing, but the point is we need to shift this sketch so that's all the way up to this top surface. So to do that, we need to figure out what the distance is from the sketch plane for this cutout to the origin. Okay, and that's how we're going to shift it all the way up to the top. So to do that, the sketch, this is where the cutout is, but the sketch was created on this plane. So select this plane, and then we want to know the distance of the origin from the origin to this plane. So select the origin, and it gives us this minimum distance, but that's not actually what we want. We only want the distance in this Z direction because that'll tell us how much to shift the sketch in this part studio in the Z direction so that it's in the correct position. So instead, we need to reselect the sketch plane and the origin, and then we're going to go down to our measure tool down here, which will show us much more information about the distances between these two. And here it has minimum distance, but then it tells us the amount of that distance that's in the Z direction, which is 10.332 millimeters. Okay, so remember 10.332. We're going to hop back over here, and we need to edit this make connector so that this sketch will be located on this face, or approximately on that face. So whenever you click this icon, we can edit the make connector. And we're just going to translate it. We're going to move it 10.332 millimeters along its Z axis. Okay. We're going to use that distance we just measured. You'll see the sketch shifts up to this top face. So the make connector is edited, and now everything looks like we want it to. Click the green check mark. And now we have the profile here. I don't believe we can edit this sketch because it's referencing the sketch from the pulley. Haven't tried. Yeah, so you can't actually edit the sketch. It's always going to be the same as it is in the pulley. But in this case, we don't need to. We just want to create a cutout in this rod using it. So click extrude from the toolbar. Go to extrude. It may look like this. Just click the derived drop down. Click this sketch. We're going to be removing material. It's going to make sure it's going in the right direction. And then we're going to use the same depth as with the pulley. It's going to be 1.5 millimeters. Okay. And there we go. And now if we don't want to see the sketch anymore, we can just hide it. And we're good to go. So that was an adventure, but just so you know, that is an option. You can also copy and paste, but if you have a complex sketch like that one, it's going to be pretty annoying. So I wouldn't mess with it if you don't have to. Okay, last thing we need to do is add some mounting holes to this rod so that the servo horn can connect to it. To do this, we're going to do exactly what I did before. It's actually the same setup. Okay. Actually, in this case, just to show you, I think this one will copy and paste successfully. So we're going to go into the pulley part studio. We're going to copy this sketch that defines where these holes will be in the pulley. We're going to copy it. Then we're going to paste it onto this face here. Okay, and it adds those holes. It looks good, but it is still underdefined. But it is simpler, so it shouldn't give us as much trouble as the other sketch did. Let's see why this is undefined. I suspect, yeah, so they aren't properly aligned and the dimensions aren't there anymore. I think that's because this was referencing the origin in the original, and so it's like referencing something external to the sketch. And so I think that's why it keeps messing up. So we're going to use some horizontal relations. Actually, first, we're going to go ahead and add dimensions because these circles are positioned correctly. But if we start adding some relations, they may move around and then we have to go find the values again. So you'll see these values are the same as the ones we used in the pulley, just because by default, these are going to be the same position. So it's more convenient to do it this way first. And remember in the original, these were mirrored, which we can just do again. We can just delete these circles and then select mirror from the toolbar. Select the mirror line, which divides the rod vertically. And select these circles. It just mirrors them across, and so they're already related correctly. And now the only thing we need to do is properly align these with the origin. So select the horizontal relation, click the origin in the center of this circle, and do the same for the other pair of circles. And now we're fully defined, so we're good. So now we need to extrude these, removing material from the rod with a certain depth. I'm going to extrude it with the depth of 5 millimeters. Okay. Now we have some holes in there where bolts can connect and connect the servo horn to the rod. Which is good. And now you'll see I've kind of lost track of my feature naming. Make sure that you're doing that as you go. I'll fix it in a second. Last thing for this body is we need to add some fillets. A fillet is just like where you smooth out a sharp corner. So for example, what we're about to add a fillet to is this sharp corner between the key piece and the curved cylindrical part. If you have this sharp transition between two parts, it introduces what's called a stress concentration. Basically, that just means the part is now much more likely to break at this point because you have this sharp transition from the key to the rod itself. And so we can reduce that stress concentration and make the part less likely to break there if we just add a curved, kind of like a sloped surface here. So if we want to add a fillet, we can go up here, select the fillet tool in the feature toolbar. And then for all of these sharp transitions, we're just going to add a 0.5 millimeter fillet, something very small. So start by saying it's going to be a 0.5 millimeter fillet. And then we're just going to select all of the different edges we want to fillet, which will be 4 edges for each of the keys. Work our way around, adding these fillets. Careful not to select. So you can fillet specific edges. You can also fillet a face. If you select a face, then it'll just fillet all of the edges that are connected to that face. So like I selected the, I can just show you again. I just accidentally selected all of this face, which means it'll do all of the fillets we want, but then I'll also do a fillet here where it meets this cone section and here where it meets this flat section, which isn't necessarily that bad, but in this case, we're just going to get the edges. Good. Okay, looks like we have all of our fillets added with the green check mark. And now the rod is finished. So the rod is in place, and now we just need to build the first link of the robot arm around it. Okay, now we'll build link 1 around this geometry. And even though Link 1 is going to be much bigger, it'll actually be much simpler to CAD. So that's good. So let's create a new sketch on this top plane. I'm going to start with a circle centered at the origin, like we so often do. This circle needs to have a 30 mm diameter. Okay, which actually is just the same diameter as this, just coincidence. And then we're going to draw a 20 mm, another circle, 20 mm diameter, that needs to be horizontally aligned with the origin. So make sure you're automatically applying that constraint. Okay. Add a dimension, make it 20 mm diameter. Okay. And then we need to add a horizontal dimension between these two. The distance is going to be 108.8 millimeters. Okay. And this is based mostly on the belt size, because I'll show you in the assembly that we're headed towards in a minute. So one thing is this pulley and this rod are actually like concentric with each other. And so the distance from the center of this rod to the center of this pulley to the other side of this link one is the same distance that will be between the center of this pulley and the center between the pulley that it'll connect to. So basically, all you need to know for this is this distance comes from the calculations that I did to determine what size the belt actually needs to be. Other than that, it's not too important that you understand where that dimension comes from. Okay, so now we're going to fill out this profile with some straight lines. Select the line tool from the toolbar. We're going to connect the uppermost points on each of these. Actually, we're just going to do it differently. We're going to select first point needs to be coincident with this circle. Second point should be coincident with this circle. Okay. Going to right click, escape line. And then to fully define that line, we need to make it tangent to both circles. Okay. Tangent to this circle, tangent to this circle. Now it's fully defined. Now we can mirror this line about this line here that divides the link horizontally. So select mirror group that's offset. Select mirror from the toolbar. Mirror it about this line. And now we've filled in our profile. Okay, and now we need to use the split tool again to divide these circles into 2 arcs each. So we're going to start the split here, end it here. Now we have 2 arcs. Do the same thing over here. Okay, and that just allows us to convert the inside of these circles to construction geometry. It's not actually necessary, but I just like it because it'll convert. Now we just have one profile, and it's this face that we're going to extrude to start making our link one. So this profile is done. Select extrude. We're going to be adding material. And so, oh, I've forgotten an important step. Okay. So we also need a gap in this profile for the rod to actually fit inside of it, and needs to be the profile of these T's. Okay. So to do that, we need to actually go back and edit the sketch again. And we're going to need to select the use tool and project all of the geometry of this cutout onto our sketch plate so that we can not have material extruded there, so there's a gap where this rod can fit inside of link one. So because of the fillets, this is kind of a pain, but we have the use tool activated in the toolbar. So we're going to go around, select all of these edges. The problem is with these fillets, you have like some sneaky edges here. So make sure that you are getting all of the little edges, or it's going to cause some problems. Just kind of how it is with the fillets. Remove the fillets, it would be much easier, but we want to have the fillets so that we reduce that stress concentration like we talked about earlier. So we'll just deal with it. I accidentally projected that point, but I don't think that's going to cause a problem, so it's fine. This is a very small edge. Okay. Probably also do this with like a circular pattern of some kind, but I'm just gonna bike through it for now. The thing is, in CAD, there's often multiple ways to accomplish the same thing. It's just there's one like most efficient way. But if you just know how to do it and it doesn't actually make your part any worse, then just do it the way that you understand. And that's fine. So we have all of the key shapes. We also need to get this circle, okay? But again, I want to get this profile also to be its like own shape. And to do that, I'm going to use a new tool actually. You could do the same thing we've been doing. You could split this circle into its own arcs, and then you could just convert the ones that you don't need to construction. I'm going to try something different this time. It's using the trim tool. So select trim. And now if you drag, click and drag, it's going to create a line. Any sketch entity you intersect with that line is going to be trimmed. So for example, I'm going to trim this line. It's going to leave the arc on either side, but it's going to remove the part that we don't want to. Okay? It's kind of hard to see that it happened, but if we rotate, maybe it'll be more obvious. It's not. Let's see. If we hover over, you see we now have. I'm not totally sure that one. Let's see. Ah, okay. I didn't actually get all of the geometry here, so I just skipped several edges. So it caused an issue. So I'm going to go through, make sure I get all of these edges projected onto the sketch plane. Okay, and now we should be good. I'm going to make sure it's a little bit difficult whenever you have so much overlapping stuff. It's hard to see what's in the sketch and what's just like a piece of a different part. So I'm going to go ahead and hide this body. It'll make it a little bit easier to see the sketch. But now this looks good, right? So you have all of the keys and you have this circle that they're attached to. So now I'm going to use the trim tool. And I'm going to just delete this section of the arc. Uh, but the other sections are going to stay the same. See, this is what we want. We no longer have that as a reference, but in this case, it doesn't make a difference. So go through, delete all of those so we have a continuous shape here. And now if I haven't done anything incorrectly, if I got all of the edges, whenever I click the check mark here, whenever we extrude, it should leave a gap for this rod. Okay, so let's try it. Select extrude. We're going to extrude. It's going to be another symmetric extrude. And we're going to extrude it symmetrically with a depth of 8 millimeters. And we need to make sure we actually select the sketch that we're extruding. And it leaves that gap, which means we did successfully project all of that profile onto our plane, which is great. Click the check mark, and then we can unhide this previous body. And now you can see we have the rod perfectly engaged with this link. Okay, and to finally finish off the CAD for this link 1, we're going to need to add 2 more simple pieces of geometry that actually allow this link 1 to connect to link 2. So we're going to start by creating a sketch. It's going to be on the bottom side of link 1, on the side away from this rod section. So it's going to be right here. Reorient the view. Now we're going to draw a circle that's going to be concentric with this arc here. So we can do that is hover over this arc and then find its center point right there. I'll do that again. And then you're just going to make it a circle there. And then we're going to make that concentric. So go to the relations menu, select concentric, select the circle we've just drawn, and then the arc at the end of the link. Oh, I misspoke. They should not be, I mean, they should be concentric, but then they should also be equal, meaning they have the same radius. So then find the equal relation, select the circle we just drew, and this arc, and now it's correctly positioned. So we're going to extrude that, adding material away from the link, just like this. It's going to be 13.1 millimeters. So the purpose of this part is it provides some spacing before link 2 sits on link 1. And in the assembly, you can see there's some space here, and that ensures that these 2 pulleys are properly aligned. So that's the purpose of that cylinder. And then we'll add one more cylinder on top where link 2 will actually sit. So create a sketch on this new face that we just created. And this circle is going to be concentric with the circle we just drew, and it's going to have a diameter of 10 millimeters. So use a dimension to define the diameter to 10. And then we're also going to extrude that, adding material to link 2, and we're going to go to a depth of 35 millimeters. And that just provides adequate space for link 2 to sit and connect with link 1. So with that final feature, link 1 is now complete. So make sure to name your remaining features, and then we'll move on to the next part.